the case may be. Had you fooled there, we are back and better than ever with a fifth of Beethoven, a classic disco tune from back in the day. Hope you enjoyed it, but let's get to it, shall we? Giddy up! All right, we are talking exponential equations, and it sounds intimidating, but it is so easy. Exponential equations have an exponent. Have a variable as an exponent. 2 to the x equals 8. Well, clearly 2 cubed equals 8, so x equals 3. But the way we can do that, looky here, I can rewrite 2 to the x equals 8 as 2 to the x equals 2 cubed. Well, if we have the same base, boys and girls, then the exponents must be equal in order for the equation to be equal, and that is all that this is saying. You will see that through a series of 4, count them 4, examples. All right, so part A. I have 2 to the x equals 32. Yes? So I have a base of 2. There's nothing I can do with that. So what I'm thinking here is, can I rewrite 32 with a base of 2? So I certainly can. 2 to the x equals 32 can be written as 2 to the 5th. Have the same base. Therefore, the exponents must be equal. Booyah. B, 3 to the x minus 2 is equal to 1 over 9. Can't do anything here, so I got to do something over here. How about this? 3 to the x minus 2 is equal to, oops, wrong place for the equal sign, is equal to 9 to the negative 1. Actually, I'm going to rewrite that as 1 over 3 squared. And we're not quite there yet, sports fans, because I need to write, let's see, 3 to the x minus 2. I need to write that so it has the same base. It does not yet, because we need to bring 3 up, equals 3 to the negative 2. Same base, therefore the exponents must be equal. X minus 2 equals negative 2, so therefore our solution is x equals 0, which probably was apparent right away. I hope it was. But this is just giving you practice, making sure you understand that you can, it's not the only way, but you can solve exponential equations by getting the same base. Because let's face it, it's all about that base. All right, so A, I don't like that song, 6 times 3 to the x equals 54. We're going to go ahead and divide both sides by 6. And we get, it's so easy. 3 to the x equals 9. You have the answer already. 3 to the x equals 3 squared. Therefore, x must be equal to 2. Oh, this looks like fun. Last example before we go back to a fit of Beethoven. 4 to the x minus 1 is equal to 1/2, all to the 1 minus 3x. We have work to do on both sides here. So clearly 2 is going to be my base. So I'm going to rewrite 4 as 2 squared to the x minus 1 equals, I'm going to rewrite 1/2 as 2 to the negative 1 to the 1 minus 3x. So then we have 2 to the exponent raised to another exponent. We multiply, careful, 2x minus 2 equals 2. Negative 1 times 1 minus 3x is negative 1 plus 3x. We have the same base, therefore the exponents must be equal. So I can now say 2x minus 2 equals negative 1 plus 3x. Or add 1 to both sides, so I would have negative 1 is equal to x, subtracting 2x from both sides. And that, boys and girls, is how we do it. Giddy up! All right, so we'll take it home. We'll smash it up. Continuing with the fifth of Beethoven. Cool tune. But as you know, I am